So now in this video we're going to look at a circuit that does the same thing as the circuit of the last video. Basically we made a night light. When it's dark the LED is on, and we don't have to get it terribly dark. The lamp's on its brightest setting. Next lowest you can see a slight glow. It's already starting to turn on right there. We could adjust the sensitivity with that resistor, but this is perfectly fine for what we have going on in this video right now. So we have a PNP bipolar junction transistor this time instead of an NPN, which is how people make most circuits, is with the NPN. But if you can make it with an NPN, you can probably make the same circuit with the PNP. You just have to remember polarities are reversed, so you're going to have to adjust components. So we're using the same value components as when we had the NPN bipolar junction transistor. The difference is the light dependent resistor is on the opposite side now of the voltage divider, and the load is on the opposite side of the transistor. So the basic principle for this, to get the transistor on, to get it to conduct, which it's not doing now because the LED is off, you need a little bit of emitter to base current since it's PNP, and then going to ground. So once you drop below about 4.4 volts in the circuit, you'll have emitter to base current, and the current will flow through the resistor. The reason why you don't have current flow now is that enough current is flowing through the light dependent resistor that it overpowers what the transistor might provide. So the light dependent resistor right now, since light is falling on it, is providing the current. But if we do get emitter to base current and flow through down there, I'll turn the lamp down so there we have that. Now we have enough resistance where we're close enough to where the light dependent resistor isn't really there anymore once the transistor is conducting fully. Not really there anymore electrically. We're above 4.4 volts. Now that allows whatever amount of current we got going through emitter to base. Probably about 200 times as much current can go from emitter to collector and through the load. Now if you notice, I'll turn the lamp off so the LED is not lit up. We have the LED on the high side, it's closer to the positive supply than the resistor. Whereas in the schematic we got the resistor on the high side, the LED down below. The LED has to be facing the same direction whether it's higher or lower, but it doesn't matter if the resistor or the LED comes first. Usually you'll see resistor then LED on schematic, but on the breadboard there it was just easier to put the LED here since resistors already are wider than stretching the LED across there. So it doesn't really matter which way you do it, but I thought I would mention that because some people worry that the order matters. They're in series, the same current's going to flow. It doesn't matter which one comes first. When the transistor's on fully, we got 5 volts basically across the total load. The white LED in this case is going to drop about 3 volts, leaving about 2 volts across the resistor, which will set the current of everything in series with it. Right now there's no current flow because the transistor is cutting off that voltage. So the transistor is a much better resistor at the moment than the resistor. That is the main takeaway. So we will come in closer again to adjust to the light levels. You can change this resistor, go slightly higher or slightly lower to make it a little more or a little less sensitive, but we're not going to go over that too much. You can see light dependent resistor positive, and then the 15,000 ohm resistor over there going to negative. It's going to the base, this jumper here. So this is 2N3906. It has the same pin layout as the 2N3904, if you know that. If you're looking at the flat side, left, which is on top now, is the emitter, which you put usually down lower because it's going to ground for the NPN. But since it's PNP, it's got to be positive, so it's more likely you'll probably put the emitter up higher. So it's facing the opposite way of the NPN. But base is the middle for this particular transistor, and a collector down there. We got collector coming to the LED instead of the resistor, long lead anode, short lead cathode, coming to the resistor, going to ground. So in any case, that covered pretty much everything. We have to get further away than about 0.6 volts from the positive supply since it's a PNP. whereas the NPN we had to get about 0.6 volts, so it was 0.6 volts from the negative supply. So it's opposite polarities. Once we drop below 4.4 volts, then we are farther than about 0.6 volts from the positive supply, and then this positive supply can kick in because we have, just like rectifier LEDs drop about 0.6 volts, so does the emitter to base. So it takes about 0.6 volts difference, so about 0.6 volts lower than the 5 volts there, to get conducting. So anything below about 4.4 should get it conducting. Hopefully that makes sense. Make sure you check out one of the other videos I post on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.